take x to the 6th, and you multiply x to the 6th times x squared, the result is the sum of those two exponents. The base, however, didn't change. If you break it down, if you factor it, x to the 6th times x to the 2nd, you end up with 8 of them, otherwise known as x to the 8th. Okay? Let's use this, and we're going to do example 2 right at the moment, to look at a couple samples really quick. First, we're going to do something kind of basic. B to the 10th multiplied by b to the 8th. I am certainly not going to do 10 b's and 8 b's just so that I can illustrate that the answer is b to the 18. Okay? 1b to the 10th multiplied by 1b to the 8th is 1b to the 18th power. Okay, remember the coefficient, the number that precedes the variable, if there isn't one, it's a 1. And you all know that 1 times 1 is 1. You'll never see me write that, but that is the truth. Where it might feel a little weird, so this is variables, is something like this. 3 squared times 3 to the 5th. You might want to say to me, well, 3 times 3 is 9. But if you look at this a little more closely, we're multiplying 3 by itself twice over here, and 3 by itself 5 times over here. The end result is still 3, but the exponent becomes a 7 because we add together the 2 and the 5. Okay? So when you have the same bases being multiplied, simply combine the exponents, keep the base. Same bases being multiplied, combine the exponents, keep the base. Okay? So, same base, you add together the exponents, but keep the base. Where it starts to get a little tricky, however, is when you end up with different bases, and I'll show you an example of that really quick as well. But one more example like this, we're going to do 2 squared times 2 cubed times 2 to the 4th. That's the last one that I need you guys working with me. Do you think it matters that there's 3 factors? Nope. 2 to the 4, 5, 6, 7, 8, 9. 9, right? 2 plus 3 plus 4. 2 plus 3 plus 4. Okay? Same base, add together your exponents and keep the base. Now, if there are, take this b for example, 1b10, 1b8 is 1b18. What if I have 5m squareds being multiplied by 6m to the 4ths? It might be easier for you to see if you commute some stuff around. Take the numbers and take the variables. Now this component here looks more like that component up there. You should end up with 30m to the 6th. There's 2 numbers, those are different, those get multiplied. Combine your exponents, okay? Take a look at the Lake Powell example. This is in your textbook. Lake Powell is an awesome reservoir in Arizona that holds 10 to the 12th cubic feet of water when full. and there are 10 to the 27th water molecules in 1 cubic foot of water. So 10 to the 27th is 10 times 10 times 10 times 10 times 10 until I've said that 27 times. In other words, 1 with 27 zeros. That's how many water molecules are in 1 cubic foot of water. And yet Lake Powell has 10 to the 12th cubic feet of water. They ask you in the questions, so then how many water molecules are in there? Well, if there's 10 to the 12th cubic feet and 10 to the 27th molecules per cubic foot, multiply them. Look at their answer there. Yeah. 10 to the 39th, so a 1 with 39 zeros, which means you're going to have 13 commas. 3, 3, 3, 3, 3, 13 commas. That's how big the number is, okay? All right. I would like you guys to look at the bottom in the checkpoint really quick with me. Bottom of page 195. I'm going to go ahead and flip my notes. Bottom of page 195. You guys with me? So this is checkpoint, page 195. We're going to do number 5. B7 multiplied by B to the second. Do they have the same base? So what will the end result be? Ben for B. 9 over B? You mean B to the 9th?
Yeah.
The little 9 floating up there. 9 over B is this.
Oh, yeah.
So be careful saying that. B to the 9th. Very good. How about checkpoint number 7? This one's a little bit different. This one goes back to the scenario where you got to maneuver some stuff. 2n to the 11th. Work it with me, folks. 6n to the 8th. Noah.
12 and 19.
Good. 2 times 6 is 12, and 11 and 8, sum, and 19. So there's some practice with multiplication, okay? We're going to go ahead and head into quotients. Quotients with respect to exponents. Normally what you're going to see from here on out, folks, you're not going to see that little division dot dot thing anymore. You're not going to see that very often. You're going to see division expressed like this. Or 36 divided by 3. Or take, for example, x to the 4th divided by x to the 2nd. And this is the kind of thing we're going to be addressing right now. When you are dividing with the same base, you simply subtract your exponents. You simply subtract your exponents. The top minus the bottom. The top minus the bottom. So the answer for this would be what? X squared? Okay? So when you are dividing with the same base, you subtract your exponents. Let's try a few of those and see what that feels like. Example 3 is where we're at now. Example 3. If I say to you 5 to the 8th divided by 5 to the 3rd, the result is going to be what? Ooh, lots of you know. Ellie. Very good. Yep. You don't say, well, 5 divided by 5 is 1. Nope. And if I had a calculator big enough to maneuver that type of numbers, I could prove it to you. But 5 times 5 times 5 times 5 times 8 times divided by 555 is that. And rather than actually state what that number is, you can just leave it just like that. Where it does get tricky, and this is where I want to show you a few more of these, is when it's numeric and variable like this, what we did up here in the multiplication thing. Examples of this in division can be a little tricky. So I'm actually going to take this exact problem and do it as a division problem. Okay. Remember how I said same base, subtract the exponents? Well, this has two different components to it. It's got a numeric only piece and then the exponent piece. You can think of those separately. Anybody know what 2/6 reduces to in fraction form? Jewel? 1/3. I left a little space for any remaining action. N11 and N8. 11 minus 8 is how much? 3. Now, you're thinking to yourself, so N cubed, does that go down there or up there? Well, it goes up here. And the reason for that is because this number is bigger. 11 minus 8 is 3. The 3 stays up there. So what you would see if this was in your book would be that answer. That's how they would show it. They wouldn't write the coefficient of 1. Let me do another one with you. Same kind of example. 7c to the 9th divided by 21c to the 3rd. 7/21, seriously? That's the other example. 1/3. Where do you think the c to the 6 goes? In the numerator or denominator, Ethan? Good. You don't have to write your coefficient of 1. Almost done, my friends. Yes, ma'am.
Can you write the coefficient of 1?
Sure, but you don't need to. Yes, sir.
For number 12, would it be 15
So we're going to go ahead and do that one since Riley brought that up. That's it. That's one of the ones I was going to pick right now, so thank you. We're going to do the checkpoint 2 items together. We're going to do number 10, just for simple practice. That's 10 to the 11th over 10 to the 7th. What's the end result for this going to be, you think? Go. 10/4. Awesome. All right. This next one, 12n5, this is number 12, just so happens to be number 12 in checkpoint, over 8n squared. Let's look at the 12 and the 8. What do you get there, Emma? So what do you get? 3/2. Very good. So we've just dealt with this component. We basically reduced it, leaving it improper. I don't know if you guys remember, but improper fractions are the new normal. N5, N2, what's the result and where does it go? Go ahead, I'm going to finish it off. N5, N2, I'm sorry, what'd you say? Where does it go, top or bottom? Perfect. Very good. Okay, the result of this division is that. Yes, ma'am.
When there's 2 different digits, why is there variable and not with this?
Here you mean?
Yeah.
There's 12 N5s. There's 12 of them. So instead of there being 1 of them, there's 12 of them. So it's just the coefficient.
Oh.
Go ahead. 3/2 you can't reduce. Make it 1.5? You don't have to. Good question. Mixed numbers are not easy to work with, but if you do, you're kind of wasting your time. That won't match the book. Yes. I won't mark it wrong if you do, though. Yes.
So, like, I have a question.
Go ahead.
Just for curiosity, like, if it's 1/2, what if that N3 and same type of time of 1/2, right?
Say again.
So if you reduce the halves to
1 and 1/2. Yeah, it would look ugly. It would look like this. 1 and 1/2, and you would put your n cubed up there. But that's like I said, you don't write it like that. This is the easier, more efficient way to write. You will never see this anymore. Okay, very good question. Last thing I want to share with you today in example 4 is what if you're forced to do a little work before doing the actual division that you're faced with. Here is an example of what I mean. Take, for example, 5x to the 4th multiplied by x to the 6th. That result divide by 10x to the 5th. Okay. There are actually a few different ways to do this. I'm only going to teach you one way. You might intuitively know another way to do it, but I'm not going to tell you that method. The end result on the top right now would be 5x to the 10th. Would you agree? 5 times 1 is 5. x4, x6 is x10. And 10x5 still sits there waiting patiently. Okay? Deal with the coefficients and you get a half, right? x10, x5, what's left and where does it go? What's left and where does it go? Eli? Numerator, beautiful. This would not normally be written this way. The coefficient would not be written. So if you checked this answer in the back of the book, this is what the book should show. Okay? If you write it that way, I know what you mean, and it's fine. But this is what you're going to see when you check your answer, so I don't want you to get confused. Okay? All right. I would like us to try number 15 and 16 in the checkpoint together. Here's number 15. Everybody go ahead and copy it with me. X times 7x5 over 10x4. Did you guys copy it? So you've got to multiply that numerator out first before attempting to divide the 10x4 into it. Hope, what's the result when you multiply x and 7x to the 5th? She's right. 7x6. The bottom is still sitting there waiting patiently. First, we'll address reducing 7/10. Anything? Nada. x6, x4, what's left and where does it go? Wonderful. Grace, go. Awesome. Thank you. Last one, checkpoint 16. $12y squared times y 8, all of that divided by 16y to the 5th. Multiply the top out, what do you get? 12y to the, Sarah? 10th. Still have 16y5 waiting. Sorry, sweethearts. Thank you. 12y10, 16y5. Let's reduce 12/16. What's the result there? Stu, go for it. Yep. My 3 became a 1 all of a sudden. All right, Stu, finish it off. y10, y5. What's left and where does it go? And top or bottom? Beautiful. Guys, that's as hard as it gets today.